Hi everybody, this is Mr. Folly, and welcome to Podcast 2.1 Naming. We're going to learn how to name ionic compounds. We're going to learn what Roman metals are and how they affect naming. We're going to learn about reducing ionic compounds. We'll learn about polyatomic ions, molecular compounds, and, hello, I'm an acid. So let's go ahead and get started. The charge from the periodic table. So with your periodic table, the charges are as follows in the columns. Whoops, I just messed it up. I should make that legible. So in the columns of the periodic table, you have plus 1, plus 2, plus 3, 0, minus 3, minus 2, minus 1, 0. Okay. Now the ones in the middle, in this region right here, I call the Roman region. Now it's kind of made up by me, and it actually goes to this part right here. The reason why they are as a Roman region is because you need to have a Roman numeral for it. So this guy's always plus 1, this guy's always plus 2, boron and aluminum are always plus 3, and then nitrogen's always minus 3. But these you don't know. It could be plus 2, it could be plus 3. They have different charges to go through this. So this Roman region needs a Roman numeral because you're going to have different ones. Now, I compare this to, in my high school, there were two girls named Amy Roberts. One was Amy Roberts, who had snaggly teeth, and the other one was Amy Roberts, who was just called the other Amy Roberts. So you didn't have to say the Amy Roberts, and you do this little hand gesture with a little snaggly teeth thing. So Amy Roberts with snaggly teeth, or the other Amy Roberts. Now, no one described Mandy as the Mandy with whatever teeth. There was just Amy Roberts was the only one because there were two of them. You don't have to describe people by their teeth unless they're both named Amy Roberts. So the only time you give a Roman numeral would be this. So for example, H plus 1 is a hydrogen ion. V plus 5 is vanadium 5. Chromium plus 2 would be chromium 2. But beryllium plus 2 is just called beryllium. Ionic compounds always start with a metal. They form networks, not molecules, and those are called formula units. Okay, so they look like this. So it's a repeating pattern, and it's a regular repeating pattern. Binary ionic compounds. Remember, we're talking about ionics, so I start with a metal and a non-metal. And you crisscross the charges. Okay, so barium, looking at your periodic table, or print one out again, barium from the periodic table is plus 2. Chloride is minus 1. So if I crisscross those charges, see how the 2 comes here and this 1 comes here, I get BaCl2. And the reason why you crisscross the charges is to cancel the charges. So I have a plus 2 charge. If I want to cancel it, Cl minus doesn't equal it yet. So Ba plus 2, Cl minus 1, and you do that. Never put charges on ionic compounds. Copper 2, copper is a Roman metal, so I have to say what its charge is. Copper, the periodic table doesn't tell me, but the 2 does. Nitride. Okay, so balance the charges to make sure that the charges cancel out. Least common multiple is 6, Cu3, N2. Notice how the 3 and 2 also crisscross to make it faster. Magnesium from the periodic table is plus 2. Oxygen from the periodic table is minus 2. Now, if you get all happy with the crisscrossing thing, you might call this Mg2O2, but you wouldn't. Remember, the goal is to cancel the charges. Those are canceled right now, so it's just McGo. Ternary ionic means I have 3 or more types of atoms. And no, AP doesn't care about those things. They care about more of the names of them in Excel. They're just ionic compounds, but they're bigger. We still crisscross subscripts and parentheses. Okay, so calcium acetate. Got to know your ions. Calcium is plus 2. Acetate is C2H3O2 negative. Okay, so now I need to make these cancel. So I want to have CaC2H3O2. And if I want 2 of them, if I put a 2 here, that would look like 22. But I want 2 acetates. Not 22 oxygens, 2 acetates. So I use parentheses with a 2 on the outside. Iron 3 nitrate. Iron is Fe plus 3 in this case because it tells me so. Nitrate is NO3 negative. Cancel those charges, and again I have parentheses, FeNO3 taken thrice. Going the other way, if I have FePO4, I know PO4 is phosphate, but I don't know iron's charge. Now looking here, I see I have one iron and one phosphate, so iron has to cancel that. So that is iron 3 phosphate. Whoops, I need to write out phosphate, don't I? Just to show you how iron 2 phosphate would be different. Fe3PO4 taken twice. This would be plus 2 from that, minus 3. See how they crisscross, but more importantly, they cancel the charge. Binary molecular. Molecular compounds are 2 or more nonmetals. And there aren't any metals in there at all. They start with a nonmetal. You just name using prefixes. And these make molecules, meaning a set ending shape. So water, for example, looks like Mickey Mouse. It's not a network of Mickey Mice. It's just one Mickey Mouse. And then there's another one, kind of interacting or not. Okay. So my advice for you is to let CO2 be your guide. CO2 is carbon dioxide. You've known that since you were, I don't know, 7. Okay. CO2 is carbon dioxide. Use your prefixes, but notice this has a 1. We don't use mono in the first one. So no mono in the first one. Nitrogen. And then use your prefixes. Dioxide. The last one has to end in "ide" and sound good. I forgot to mention that over here. For the ionics, especially the binary ionics, the negative ion will end in "ide" and sound good. Okay, so chlorine isn't chlorine, it's chloride. Nitrogen isn't nitrogenide, it's just nitride, and so on. So, sorry about that. Carbon tetrachloride, notice there's no prefix for the first one. So, whoops, it's C. I have one of them, right? Tetrachloride would be chloride is Cl, CCl4. Now if I had dinitrogen, tetroxide. Dinitrogen is N2. Tetroxide would be O4. Notice how these, you do not reduce them. Hello, I'm an acid. Acids start with an H. It says, hello, I'm an acid. They're ionically bonded, but does not form a network. So if I asked how are acids bond together, it's ionically, that's it. 8 turns into something, ic, acid. 8 turns into something, us, acid. And ide turns into, whoops, me writing a line too soon, hydroic acid. So again, you need to know your ions. ClO2 is chlorite. So it becomes chlorus acid. Now how did I know this is an acid? Starts with an H. Hello, I'm an acid. H2SO4, it's an acid. Hello, I'm an acid. SO4 is sulfate. 8 becomes ic acid. Make the stem that sounds good. Sulfuric acid. If I have hydrobromic acid here, the hydroic acid. Hydroic acid comes from ide. Bromide is Br negative. I need to have the number of hydrogens that will cancel that. H is +1, see periodic table. So that means hydrobromic acid is HBr. Hydrates. Loosely bonded water to an ionic compound. It is one compound. This, people think, is 2 things. This is not 2 things. Wow, that's bad handwriting. It's a network with one ionic compound surrounded by water molecules. So what I do is I name this part copper. Hey, copper, you're in the Roman region. I don't know your charge. Copper something sulfate. Now because I know sulfate is -2, copper has to cancel that -2 charge and be +2. So copper, Roman numeral 2, sulfate, and then the water part, hexahydrate The prefix for 6 is hexa. Okay. MgCO3, magnesium is not Roman, so it's just magnesium carbonate. Three, prefix is trihydrate. Aluminum sulfate, aluminum plus 3, C-periodic table, sulfate, SO4 minus 2. Balancing those charges would give me Al2, SO4. Tetrahydrate is dot 4H2O. Ding. Review. Now here's the review part I forgot to do. 1 is mono for your prefixes. 2 is di. 3 is tri. 4 is tetra, like my favorite video game. Tetris has 4 blocks. 5 is penta. 6 is hexa. 7 is hepta. 8 is nona. And 9 is, wait, 8 is not nona. 8 is octa. And 9 is nona. 10 is deca. Names are systems we must learn. The first type of atom identifies it. Know your ions, and remember a formula unit is what you call a grouping of ionic compounds. So if you go around town with the girl I love, it's like, formula unit, All right, CeeLo, I get it. Toodles.